Hey there! So last time we did some data transformations using Azure Databricks. Great, but actually I didn't save the results anywhere, like to a data lake. So the results of my transformations were lost. Once I closed the Databricks notebook, they disappeared. And basically we would like to persist our transformations, our results. And that's the topic for today. So let's get started. Alright, so let's talk about the way we can persist results of our data transformations. And today we'll be doing this on a data lake. So the results of our Databricks stuff will save back to a data lake. But please be aware that it is not the only place to which we could save the data. For example, I could save it to Azure SQL database or to Synapse SQL pool or any other target, but today we'll just focus on a data lake. So let's jump into my Databricks notebook and let's start doing stuff. And you should remember that whenever we want to access a data lake from a notebook, we have to configure this connectivity part. So Databricks would know how we want to connect. And so far I was doing this as one of the first cells in my notebook. So the scope of this configuration was limited only to this particular notebook. And it worked fine, but today I'm going to make a change. So today, instead of doing this at the notebook level, I did this at the cluster level. And in a second you will see why I did this change. And if you would like to follow my steps, then simply go to Microsoft documentation about connecting to a data lake, the stuff that we've been using previously. And if you scroll down a bit, you will find the code that talks about using a service principal. Basically this technical account in the context of which we are connecting to a data lake. And previously, I used this set of code to configure this in a notebook. But above here, you can find a code that you could use to configure this at the cluster level. And it is basically the same code, so you will find here the same placeholders that you would have to modify and put your real values there. And the place in which, or the place where you would put this configuration is your cluster. So let me go to my compute, to my demo cluster, because that's the cluster I'm going to use today. And here in its configuration, so if you would click on this edit button, you would go to advanced options, and here you'll find your Spark config. So that's the place to which you would have to paste this code from documentation. And then you would have to restart the cluster. And it should work. So from now on, every notebook, every code executed on this cluster should be able to connect to a data lake. So let's go back to my notebook and let's verify if the connectivity works just fine. So let me paste the code that simply tries to connect to my raw container on my Table Data Lake demo data lake and just list the contents. So if I run it, it should work just fine because the connectivity was configured at the scope of my demo cluster, which I'm using in this notebook. Great. So the connectivity part, security stuff is handled. So let's move on. So basically, to practice saving data back to a data lake, we need to have some data that we would like to save. And basically, we'll reuse the same transformations that we did the last time. So let me quickly copy the code that would transform our replicable JSON data into this nice tabular form that we'll later save to a data lake. So basically this cell, what it does is it reads this minifix JSON file from our data lake. It explodes the array, and then it makes this data frame available in my SQL queries as my data temporary view. So let me run this. And then let's copy the query that was actually responsible for transforming our data. So let me add a SQL query. So that's the one. The same stuff that we did previously. And if I run this, we should see this nice tabular data. That's the one that we would like to save back to our data lake. So we have our data. So now let's go into the most important part of saving the data to a data lake. So first, we've got to decide, all right, but where we want to save this data on our data lake. So let's revisit it. And you can see that we've got multiple containers. And basically, this row and confirmed, they were created to represent various layers on our data lake, various stages of data processing. So let's simply add a new container. I will call it curated. You can use whatever name you like bronze, silver, gold, curated, confirmed, standardized, whatever you need. And basically, I will use this curated container as a place to which we will save the data. And obviously at this moment, it is empty because there's nothing in it yet. And there are multiple ways we could use to save the data to a data lake. So let me start with the simplest one. So here we'll just grab our data, this table, and save it to a data lake as Delta files. And that's it, nothing else. And to make it work, let me use a Python command. So let's add a new cell, and you should remember that the results of my SQL transformations is available in this underscore SQL df data frame. So let's start with using this data frame. All right, and I know that my statement will be a multi-line command, so that's why I'm using these slashes. Then I know I want to write to a data lake, so I will use write command. Then I will explicitly define the format of files that I would like to be used, like Delta, not CSV, not Parquet, just Delta. That's the preferred format. And finally, I've got to just provide a path to my data lake where this data should be put. And here I will simply copy this path, and I will replace this row container with our curated. And I think that's it. So the data, the results of our transformations, should be saved to curated container on my table data lake demo data lake into replicable /minifix directory. So let's see if that works. Hopefully it will, because the connectivity part is handled, networking should be working, and yes, it succeeded. So something happened. So let's revisit our data lake, our curated container. Let me refresh the content. And there it is. We've got our replicable directory. Then we've got our minifix directory, inside which we've got our data saved as Delta. So you can see this Delta log and the files that are using a Parquet format. And there it is. So it's done. So we simply were able to save the data back to a data lake. As simple as that. All right, so let's verify that this data can be actually read, that it is not malformed in any way. So again, we'll use Spark read command just to try to read the data that we just saved. So Spark read, again, let me explicitly indicate the format, Delta. Then I've got to provide a load statement and finally a path to my directory on a data lake. And to format the results in a nice table, let me use this display function. And it should display our data. And there it is. So it is a proof that indeed the save part worked, and we were able to read the data back to our notebook and then use it for some later processing. So mission accomplished, right? We could just end the episode here. Almost. Because take note what I had to do when I wanted to read this data. Mainly, I had to provide this full path to a location where this data is stored. And apart from this, I had to provide a format which was used to save this data. So I would say that these are those low-level technical details that end users or other data engineers might not be familiar with. And maybe you would like to make their lives easier just by hiding all those details and exposing an object with a nice user-friendly name that they could use in their queries. So they wouldn't even bother about the location of the data. They would just use some user-friendly name. And yes, that's possible. So let me show you another way of saving the data to a data lake that will do something extra. So namely, we will register our table in a catalog, in a meta store, that will allow later some other users to use it by this user-friendly name. So let's do this. So here I will switch to SQL because for me SQL is the best language out there. And I will create something called a database. And you might be confused that what Databricks, is it a database server? No, it's not. Here, database is just a logical container that will store definitions of your objects. And in a second, I will explain what it means. So let me create a database. I will call it Piotr demo. Let me run this. And at this moment, somewhere, this database was created. And it doesn't use some Azure SQL database or Azure SQL server under the hood. No. It is possible, but not at this moment. We'll get back to this. And then, since we have our database created, let me create a table. So again, let's switch to SQL and let me create a table. So create table. I will indicate which database I want it to be put in. So it was Piotr demo. Dot. Let me then give a name of my table, like minifix as, and then let me write a query that will populate the table. And actually we already have our query because it is here. So let me simply copy this query and paste it in my table definition, like so. So what this statement does, it will create this table called minifix inside Piotr demo database, and it will populate it with the results of this query. So let me run this. All right, so something has been done. But what's the benefit of creating this table and database? And let me show it to you. So now, let's assume that you are some end user that would like to use this data that you just created. So instead of having to read it using explicit path to a data lake, they could now use this user-friendly name, like using a select statement. For example, select star from my database, Piotr demo.minifix. And let me run this. And there you go. You've got your data that is persisted somewhere. So even if I close this notebook, even if I shut down the cluster and then rerun my query, this data will be still there because it has been persisted somewhere. And take a look how easy it is now to use this data, because all the users would have to know would be to which database and which table to use. So they might not even be aware that this data is stored somewhere as Delta files. So that's a huge benefit to them. And now you might start wondering, all right, but how those users, or how you as a data engineer, would know what databases and what tables are available in your environment? And that's where this catalog option will come in handy. So let's take a look at what's stored there. So I told you that when we created this database and table, we registered it somewhere. So we made this definition available somewhere for other users to use. And this catalog, this meta store, is simply here, available under this option. And here you would see this Hive Metastore catalog. And at this moment, you might think of it like a catalog of objects that are registered in your Databricks workspace that you can later query. It will change a bit when we start using Unity Catalog, but for now, just think of this Hive Metastore as a catalog of things, of objects that are available. And here you can see two databases. Default one that is available out of the box, and the one that we've just created called Piotr Demo. And under this Piotr Demo, you will find this minifix table. So that's how your users might see what data is available there. And actually, instead of Piotr Demo, maybe I should call this database curated, just to match the logical layer of my data lake. And now, if I click on this table, you will see here its structure. The structure that was derived based on the select statement that we use to populate the contents of this table. You might see some sample data. Here in the overview, you will see that it indeed uses a Delta format. So that's how your users might be able to understand your data. But you, as a data engineer, you might start asking questions like, all right, but where is this data stored? It uses Delta format, and you know that Delta is a file format. So those files have to be stored somewhere. Are they stored on your data lake, on this, or on this stable data lake demo data lake, or somewhere else? So to answer this question, let's go into Details tab. And here you will find two important things. So first of all, that the type of this minifix table, it is managed. So basically it is managed by Databricks, not you. And the location, that it is the data of this table is stored on dbfs user hive warehouse Piotr Demo db minifix. And this dbfs parts, it stands for Databricks file system. And simply managed means that the location of this data was taken care of by Databricks, because me, as a data engineer, I didn't provide any details about this table. I just asked Databricks to create a table, and that's it. And Databricks was kind enough to accept this request and create it somewhere in a location that is managed by Databricks. And you should already remember that there is a place that is managed completely by Databricks workspace. So basically, whenever we create a Databricks workspace, it automatically creates a resource group with a similar name to your workspace. So in my case, it is Databricks RG Demo DP23 something something. And in this workspace, we've got various resources that are required by Databricks to work. For example, you will find here virtual machines that are used by our clusters. And also, you will find here a data lake with some strange name that is used by Databricks. And because I didn't provide a path to my table explicitly, what Databricks did was to store the data on this data lake in some location. Great, but the thing is that the whole resource group is not managed by me. It is managed by Databricks. And even though I'm the owner or admin of the whole Azure subscription, I have no power here. So if I try to go to the storage account, to those containers and take a look at some data, it will say that, sorry, you are not authorized, because it is completely managed by Databricks, not by me. So it also means that the only way to get access to data stored in this data lake is to use Databricks, which is not that great, because you might have some other services like Data Factory that would like to connect to this data. And that's not possible without going through Databricks. And secondly, because you have no control over this data lake, you are not able to set permissions here using ACLs or role-based access control. So maybe it's not the best way to store your data here. And actually, if you go to Databricks documentation, they say educate users to not store data on DBFS routes. So they say don't store data there. Use your own data lake. And we'll do this in a second. But before we go there, let me quickly draw the scenario that we've just created, just to help you understand what actually happened. So we have our Databricks workspace. So this is our Databricks workspace. Let me show it. So this is Databricks. And you should remember that Databricks is a compute service. It is not a storage service. So Databricks on its own, it doesn't store the data. It needs some other service that will store it. So for storage, it uses a data lake. So let me draw a data lake here. ADLSg2. And what we did was to create a table of database first. So let me draw a database. So this is a database. And inside this database, we created a table, this minifix table. So this was minifix. But a very important thing to remember is that the data is not stored somewhere in Databricks. No, it is stored on the storage layer. And because we didn't provide a path explicitly, Databricks managed it for us. And it used its own data lake. And the data was stored physically in a location, somewhere under root, then user, I think Hive, warehouse, and so on. But the thing to remember is that this is inside Databricks managed resource group. So Databricks managed RG. So this was a managed table. Managed. All right. So one more time. The definition of our data, database and table, is stored on a Databricks site. And actually, it was stored in something called Hive Metastore. So let me write it down. So Hive Metastore. Metastore. This is our catalog. It is just a catalog of our data. It contains only metadata about our data, definition and location. But the actual data is stored separately on a data lake. And in case of managed table, it is stored on a data lake that is managed by Databricks, which is not recommended actually. We have our own data lake with those beautiful zones, wonderful containers, inside which we would like to store the data. So there has to be a way to tell Databricks, great, I would still like to register my table in this catalog, but please store the data on my data lake, not on yours. And yes, that's possible. So let's create something called external table. And that's exactly the scenario that we need. So let me go back to my notebook and let's create a new table. So let me copy the statement that we used previously, because our new statement to create this external table will be almost the same. So let me paste it. Let me change the name of my table just to be able to distinguish them. So let me call it minifix external. And the thing that we've got to provide is the location of our data by using this location phrase. And here, let me simply provide a path to a data lake. So let me copy the same path that we've been using so far. And let's change a directory from minifix to minifix external, or whatever name works in your case. And let me run this. So what's happening right now? Again, Databricks is registering my minifix external table in this catalog. So the name could be used in regular queries, but this time data is saved on my data lake. So if we go to this replicable directory, this time we see two directories. So the first one was created when we just saved the data directly to a data lake without creating a table in the catalog. And the second one, this external, was created together with a table, but this time we provided explicit location. So if we go back to the catalog, I should see this minifix external table that is registered in the catalog. It is available there. But if I go to details, you will see a difference compared to the previous table, because this time the type is set to external, which means that from Databricks' point of view, it is stored on some external location, not on its own data lake. And here, under location, you can clearly see where this data is stored. And even you can see the sample data. And now you might start wondering, all right, but how it is possible that here, when I'm browsing the catalog, I'm able to go to the data lake and query this data? And the answer is the configuration we did at the cluster level, the configuration to connect to a data lake. Without this stuff, I would get an error here that, sorry, Databricks doesn't know how to connect to this minifix external table and display its details. So that's why I moved the configuration from the notebook to the cluster. So let's revisit our diagram and let's add our external table option, which is preferred. So this time we saved the data in our data lake under curated directory, then replicable, and so on. But this time it was our data lake, which is preferred option, and it is called external table. Like so. So you can see that we've got three options. We can save the data to a data lake without creating a table in the catalog. It's possible if you want to do this, but if you'd like to register this data in the catalog, you can create it either as a managed table or external one. And external is the preferred one, because we've got full control over our data, how it is stored and where. Alright, so let's revisit our notebook and let's see what we can do now with our data. Like, can we perform various operations on it? But before we go there, let me show you one more thing that you can use to quickly upload some data to Databricks. So here at the top, you can see this new button that allows you to create various new things like new cluster, new notebook, and also to upload some new file. So let me find some CSV or JSON. Actually, I will just drag my minifix.json file. And here you can indicate where in the catalog and database and a table you would like to save this data, or under what name. And take a note that here they use, in Databricks world, they use schema as something similar to a database. And I will back to this in a second. So let me quickly choose my database. Let's call it minifix imported. And that's it. The rest of the options is fine. So let me just create a table. So that's how you can quickly add some test data that you would like to work with without going through a code part. So you can see that indeed we've got this new table, minifix imported, but it was saved as a managed table. So it was saved on this Databricks managed data lake. So maybe not the best thing to do. And now let me revisit this schema and the database topic. So especially if you are coming from SQL Server world, you might be surprised, because in, let's say, Microsoft SQL Server, we've got 4 parts of the object name. So it is like this. It starts with a server name. So in SQL Server, it is like this. We've got server dot, then we've got database dot, then schema, dot, and object, for example, some table. So let's say that we've got a server called SRV01. Then we've got database called AdventureWorks, like AdventureWorks. Then schema DBO, or sales, or HR, whatever, DBO, and the table or object, in our case it will be a table like sales. So we've got those 4 parts of the name: server, database, schema, and object, which allows us to create this nice hierarchy inside the database. And for example, group some objects within the same schema, like various HR objects, various sales objects together. But inside Databricks, it is different. So for Databricks, they use only 3 parts of the name. So we've got our catalog. Then we've got a schema or database, because for Databricks, schema is simply a synonym of a database. Database, and then we've got our object. And this might be confusing to you, that schema is the same as database, especially if you are used to have this distinction on these two. It also means that you might think how you would like to organize your data within this catalog, to make sure that it won't result in a total mess. But it's up to you to decide how you want to handle this. And again, when we start using Unity Catalog, it will change a bit. All right. So let's go back to our notebook. And we have our how many tables created? We've got 3 tables registered. And I will be using this minifix external because that's the one that stores data on our data lake. So it will be easier for us to see the changes on the data. So let's go back to a notebook and let me add a new query. So first of all, let's see how many rows we've got in our minifix external table. So let me write a simple select count statement from my database, Piotr T. Demo. It was called minifix external. So how many rows do we have? 14,144. All right. So let's add a new row. And again, for SQL, that's super easy. You just write your regular insert statement. And you'll be using this name. So I totally forget about the fact that this data is stored on my data lake. I don't care even. I will be using this user-friendly name to work with my data. So let me copy an insert statement that simply adds a new row, a new minifig with this fig xxx1 as a set number to my minifix external table. So let me run this. And it is just a regular insert statement which succeeded. 1 row was inserted. So if I rerun my count statement, we should see 1 more row. And indeed, the number changed. And let's see how the data changed on the data lake. And because this data is stored on our data lake, it is perfectly fine to go there and see the changes. If it was stored on a Databricks managed data lake, we wouldn't be able to go there and see the files. And yes, you can see that actually this file is a new file that was created with this new row. And in the log, there is a new version of our data. So by using this regular insert statement, I was able to interact with the data saved as delta, which is super cool. All right, so let me verify that this row really exists in my table. So let me run a select statement where I would find or where I would look for this newly added row, just to verify that it really exists there. So hopefully, oh come on, I used in a valid table. So yep, it is there. So it is a proof that indeed this row exists. And this data, by the way, is persisted. So even if I stop the cluster, if I close this Databricks notebook, it will be still there. And it will be also accessible by other Azure services like Data Factory, if I would like to do this for some reason. All right, so we know that we can insert new data. So let's now try to update it. And again, I will just use this regular update statement. So let me copy my query. And what I'm doing here is that I'm updating my minifix external table, this newly created row, and I'm changing its name from new minifig 1 to updated minifig 1. So let's run this. And now Databricks is checking the data. It checks which files it has to modify, and it updated 1 row. So let's rerun our select statement, and we should see, yep, updated name. And again, if we revisit the data on a data lake, there should be new version of our data. And there it is. So we've got select, insert, and update statements covered. Super easy. So the last of those basic data manipulation queries is the delete statement. So let's try to delete the row. So again, I will be removing data from our minifix external table, the row that we've just created. So let's run this. And one row was affected. So one row, I hope, was removed. So if I try to find it this time, it should return no results, because this row no longer exists in my data, in my table. And that's it. So you can see that registering the table in the catalog, in the meta store, is super useful, because from now on, I can use those user-friendly table names to interact with my data. And I don't even know, and I don't care where this data is stored and how to access it, because it is handled at the cluster level. Maybe some Databricks administrator did it for me, and me, or you, as a data engineer, you just need to write your SQL queries to work with this data. And the rest of the stuff is already prepared for you. All right, so let's move to another topic. So when I was talking about those slowly changing dimensions, I told you that in many cases, you would like to have this artificial ID column that you could use to uniquely identify a row. And it is especially important in the case of SCD type 2, where you version your data, because you might have multiple versions of the same row. So multiple rows with the same business ID, which means that you cannot use it to identify the row, because there will be duplicates. And for example, in Microsoft SQL Server, we have this identity property that you could set on some column to ask SQL Server to automatically generate values for this column, like 1, 2, 3, and so on. And for a long time, we didn't have something similar in Databricks, and some other options, some other techniques had to be used, but now we have it. So we can also here use this identity property. So let's use it. So I will create a new table called PiotrTDemo minifix identity that has the same schema as previously, but please that this time I'm providing the schema explicitly. And I'm also adding a new column ID of a big int type, which is marked as identity. So these values of this column will be generated automatically by Databricks. And I'm providing a location for my table on my data lake, like so. So let's create this table. It has been created. It is empty at this moment, but it is already registered in the catalog. So let's add some rows to it. And again, I will use some SQL query. So what I'm doing here is that I'm inserting data to my table, and basically I'm inserting the results of my select statement. That's it. But please note that I'm not providing a value for this identity column, for this ID1, because it is handled automatically by Databricks. So let's run this command. Let me copy the name of this table and let's query it. So you should see that even though I didn't provide values for this ID column, the values are there, created automatically by Databricks. That's super cool. But you also can see that, hey, there are some gaps, like 1, 3, 5, and so on. And yeah, that's true. Because this identity property, well, it doesn't guarantee that there will be no gaps between our numbers. That's how this distributed engine works. But that's fine. In many cases, all we care about is that those values are unique, because we'll use it to identify a given role. And this identity property, it meets those requirements. So that's how easy it is to generate this artificial ID. And basically that's it for today. So to summarize, you should see that writing your data back to a data lake is not that complicated. And actually there are multiple ways you can achieve this, depending on what you want to achieve. Usually, you would like to register the name of your table, or you would like to register your data in the catalog. So it will be easier to use it for some data engineers or data or end users. And when you're registering a table to a catalog, you can indicate where this data should be stored. If you do this, if you provide a location, then this table will be considered external to Databricks, and it will be stored on the path that you provide explicitly. If you don't provide the location, then Databricks will take care of it for you. It will manage the table, and it will use the data lake that is available together with Databricks. It is called a managed table. But if you don't want to bother with registering your table, you don't have to do this. You can just save your data to a data lake, and that's it. So that's it for today. I hope it was useful, and see you next time. Take care.